Today's date, it'll be HMH7 heat pump training overview. And today's date, 06/02/2022. Okay, fellas, I'm going to share my screen here real quick with everyone, and we're going to got a little PowerPoint we're going to cover this morning. And so I'll let you guys kind of be the monitors as well. It's, you guys have got some good audio feed this morning, so there's not any background noise that I can hear. So go ahead and just keep your mic open and ask those good questions. And we're going to go ahead and open up that PowerPoint. And if you guys wouldn't mind, we'll make sure you guys can see the PowerPoint okay. If you can't see the PowerPoint okay here in a second or two, please say something. And so everyone should be able to see that opening slide. There's two pictures of the outdoor product. There's a 2-fan model and a single fan model. Can everyone see that okay?
Yep. Yeah, we got it.
All righty. Well, fellas, kind of kicking off a little bit, one of the things I like to always start with our heat pump overview is the fact we've actually got two footprints, if you will. We've got a 2-fan model. That's going to be the 4 and 5 ton model. And then the single fan model will be the 2 and 3 ton model. So they come in whole tonnages, 2, 3, 4, and 5 tonnages in whole tonnages. These units modulate on the outdoor unit from 35 to 100% capacity, even though we're going to use a conventional thermostat inside. And a conventional thermostat, what I mean by that is your favorite 24-volt thermostat. So it wires up like any other single-stage heat pump. It wires like a single-stage heat pump, except it actually modulates outside 35 to 100% capacity. In addition, we get a lot of questions about the outdoor unit because it kind of looks like a mini split, with the horizontal discharge and all, but I want to stress something. It is not a mini split. Now, it shares some similar technology on the compressor in the fact that it is a modulating compressor from 35 to 100% capacity. But on the indoor coil, we use just a conventional plain Jane expansion valve. It isn't anything special. So you're going to wire it like a regular heat pump. There's a couple of exceptions we'll talk about. It's 24-volt wiring. It's a simple heat pump thermostat on the wall, and it's a conventional plain Jane everyday expansion valve on the indoor coil. So nothing special there. And again, it modulates at 35 to 100% capacity. So as we take a look at this unit, I would like you to remember something though, that just like a mini split, it uses similar technology on the hose fittings. So you're going to need to have one of these 5/16 flare adapters to go from 5/16 flare to 1/4-inch flare for your service hoses. And a lot of people make those. You guys probably have some on your truck anyway if you guys work on mini splits. But Robin Air makes them, JB makes them, Yellow Jacket makes them, so they're very readily available. But you're going to need that 5/16 to 1/4-inch adapter to get your service hoses on these things, so you can service them like you would just a normal unit. The other thing we get asked quite a bit is the temperatures. How low and how high will these units operate? And so you can see right here. This is right out of the install information, by the way, fellas. So you can see that the minimum cooling is 35 degrees, and the minimum heating is -5, which I hope you'd never see down there in your area of the woods. But still, it's a 35 for cooling and -5 for heating on the outdoor coil, and then maximum 122 degrees outdoor temperature, and for heating a maximum of 75-degree outdoor temperature. So you can kind of see that, it has some really good capability and has a lot of range, if you will, on cooling. And this is right from the factory now, all the way down to -5 in the heating mode of operation. So that's pretty neat. So any questions or comments so far before we jump into our program after that little introduction?
Nope.
Everybody good? Okay.
Yeah, we've done a few of them so far.
Okay. All right. Well, fantastic. So fellas, at this time, what we're going to do, we're going to jump into the low voltage wiring of this heat pump. And we're going to be focusing first thing on this morning on the AE air handler, which features just a standard ECM type of motor. And then later on in the training program this morning, we'll also jump on a variable speed air handler, because I know you guys have a real heavy air handler market down there. And the variable speed air handler works very, very well with this thing as well. So we're going to start out with the low voltage wiring with the AE air handler, and we're going to just look at a simplified block wiring diagram that I generated for this. And remember now that the AE air handler does not have any terminals on there, but they're pigtail connections, as you guys know if you've hooked some of these up. But what I've done on the PowerPoint, I've made kind of a little terminal or a little block so that you could see where it hooks up, even though I know there's pigtails on those connections. We're also going to talk about wiring that accessory single pole double throw relay in the indoor unit and how it's going to be used for airflow reduction. So I'd mentioned earlier that this unit modulates from 35 to 100% capacity outside, but what it does when it hits about 60% capacity, 60 to 65% capacity, it's going to send a signal inside to a relay to reduce the airflow on the indoor coil to give you a more closer match between the point of modulation or capacity outside and airflow inside. So when we hit about 60, 65% capacity, it's going to generate a signal, and we'll talk about that S1 signal here in a little while, but it's going to generate a 24-volt signal to switch a relay to reduce the airflow inside, so the indoor airflow is more closely matched to the capacity of the outdoor unit. And so we're going to recommend this kit number HMH7AK001 for convenience and the supplied parts. Now, what I mean by that is this: that kit, that relay kit, actually comes with a biflow filter dryer and some pre-made wiring harnesses and stuff like that. So it's got some pre-made wires. You don't have to make up these field wires. And then in addition, it also has the relay on a little control board. So it's really convenient to just buy the kit. Now, the burning question comes sometimes. I've had contractors call me and say, Joel, I can't get this kit, and I got to get this thing in tomorrow, and I don't have a kit. Can I make up my own kit? Well, the answer is, of course you can. All you're going to need is just a peanut relay. I recommend a sealed peanut relay, a single pole double throw relay with a 24-volt coil. You'll have to provide your own biflow filter dryer if you make all this up yourself, and you're going to have to provide some field wiring from the relay over to the indoor unit, to the motor and stuff like that. So you can make these up yourself. I mean, you can do your own biflow filter dryer and all that stuff and make up all your own field wiring. And we've had some contractors up north actually do that because either they couldn't get the kit or they just wanted to do it themselves. So you can use just a single pole double throw relay. If you're going to do that, though, I recommend a sealed relay. It's one of those little peanut relays with a 24-volt coil, and then you can do it that way. But like I said, I recommend for convenience and supplied parts to go ahead and get the kits. That makes it pretty easy and straightforward. In addition, we're going to recommend that you always have a heat pump thermostat with a BO selection for the reversing valve operation, because unlike the rest of our Champion product, this product energizes the reversing valve in the heating mode of operation. And so it's not bad, it's just different. We just need to accommodate that. And just remember that if we're going to be using it in a heat pump configuration, we want to make sure and have a thermostat that has a BO selection so that we can energize that reversing valve in the heating mode instead of the cooling mode like we do on our other Champion products. So with that, let's go ahead and start looking at just a simplified block wire diagram on the AE air handler. And so we're going to literally take it wire for wire, guys, from the thermostat on the left-hand side, you can see, to the indoor unit, to the outdoor unit. And so that first wire we're going to talk about is that B terminal. And so the B terminal energizes the reversing valve in the heating mode of operation. And please remember, your thermostat has to have that selection for BO for heating operation on the reversing valve. And so if you've got a two-stage heat strip, we're just presuming you may have a two-stage heat strip in there. So W2 from the thermostat will go to W2 on the air handler. That'll be your second stage auxiliary heat. And then your W1 will be from your thermostat first stage auxiliary heat to the indoor unit to the outdoor unit. Now, guys, please remember, we want to carry that on a heat pump here. We want to carry that all the way outside, that W, or that W1, so that we can bring the heat strip on during defrost. That's what that W wire outside is for. coming back inside to W1 is to bring the heat strip on during defrost. Then your Y terminal is going to be your compressor call. Now you're going to note something that on some models of air handlers, if it's so equipped, you're going to see a yellow wire on the ECM motor. Now we're going to ask that you typically just remove that because we're going to be selecting some different speed selections on that ECM motor here in a little bit. And so the normal recommendation, if you do have a factory yellow wire on the ECM motor, go ahead and take that off because we're going to be probably utilizing that speed tap, and it may not be the one that the yellow wire is on. So go ahead and just remove that, and then we'll talk about what we're going to do with that relay and how we're going to hook all that up here in a little bit. The terminal goes all the way through from the thermostat to the indoor unit to the outdoor unit. That's our 24-volt common wire. And then our R terminal is going to be our 24-volt hot. Now, please note something, fellas. It does not go outside. We don't take 24 volts out there all the time to the control board like we do on most of our other heat pump products. So the outdoor unit does not require that R terminal outside. So 24-volt hot goes from the thermostat to the indoor unit, and it does not go outside. G terminals are fan call, and what we typically recommend is just on your G call, go ahead and put that on your lowest speed tap. So on your ECM motor, that'd be like speed tap number 1 for your G call. And so what that's all about is if the homeowner goes over to the thermostat sub-base assembly and selects fan on, when nothing else is running, they just want to run the fan to circulate some air in the home, it'll go ahead and be on the lowest speed tap. So you have that really nice, quiet, continuous fan if it's so desired. So we recommend that, and that's very, very typical. You know, you'll find that on most applications, if you want just fan only, it's normally the lowest speed tap. Any questions or comments so far on the low voltage wiring before we start jumping into the relay and how it's going to work and some of those other finer points? Any questions or comments so far?
Yeah, so if we're breaking for like load switch or something, you break red.
Okay, I didn't hear the question real good. Say it one more time, please.
Should we break red like on a secondary float switch or something?
You probably could. It wouldn't hurt anything to do that. Normally, what I recommend though is if you're going to use like an auxiliary float switch, just break the compressor call, the Y signal, because if you break the Y signal, it'll go ahead and not allow operation on the outdoor unit. But the R terminal would be okay too to the thermostat because that feeds power to the thermostat. So based on the type of thermostat you have, you may not want to break the red because it's because that R terminal kind of powers the thermostat up, and in some thermostats they like to stay powered up as far as some of their functions and stuff like that. But that would work. But I would recommend the Y would probably be a little better for an overflow or like a condensate switch.
Thank you.
Good question. Excellent question. All right, fellas. So as we start taking a look at some of the finer details on that relay, so what we're going to do, there's going to be a terminal outside called S1. S1 is going to be our airflow reduction signal from the outdoor unit. And we're going to take that to one side of our relay coil. It's a 24-volt signal. The other side of the relay coil is going to go to common. And that makes sense so that we complete that coil circuit to operate that relay. So S1 will go to one side of the relay coil. The other side of the relay coil will go to common to complete that 24-volt circuit when we get that signal. Now the common terminal for the switching contacts will go up and grab that yellow wire or Y terminal going outside. So basically anytime we have a compressor call, we're going to have power to the common terminal of the switching contacts. On the ECM motor itself, our high-speed tap, before we get into our other speed taps, our high-speed tap is typically going to go on your W. So what's going to happen is that if you get an auxiliary heat call, or if you get a defrost call outside, it's going to drive that motor to high speed for safety. Because remember, if we're bringing in heat strips, we want to make sure we have our full airflow so we don't overheat the heat strip, right? And so it's very typical that we'll, when I say typical, I mean this is how they're normally wired, where high speed will go to your auxiliary heating call. Anytime you have a heat strip call, it'll drive that fan to high speed. And so wanted to show that one real quick too before we get into the other speed taps. Now, on the normally closed contact of the relay, the switching relay, we're going to go over and we're going to select on the ECM motor 100% cooling airflow. So let's say, and guys, we always want to set this airflow up for about 350 to 400 CFM per ton. Nominal airflow is going to be 400 CFM per ton when we design our ductwork and all that stuff. But down there in the area you guys are, you may want to reduce that airflow a little bit to help your humidity control. And I'm okay if you go down to 350. Don't go any lower than 350 for airflow reduction. For 350 CFM per ton, because you don't want to ice the coil up or anything like that. But so grab that normally closed contact on the relay to the ECM motor to give you 100% cooling airflow at a baseline of 400 CFM per ton. So let's say, for instance, we have a 3-ton unit outside. We need 1,200 CFM on that 100% airflow tap. Or if we have a 2-ton unit outside, we need 800 CFM on that normally closed contact for that airflow tap. So when you guys are setting the air handlers up and you're taking your airflow measurements and stuff like that, you're going to select the speed tap on that motor, on that normally closed contact of the relay to give you 400 CFM per ton of cooling capacity. So again, if you got a 3-ton unit outside, that speed tap, that 100% airflow speed tap needs to be about 1,200 CFM. Any questions or comments on that so far?
No, I think we're good.
Okay. So the normally open contact on that relay, we're going to go over and we're going to grab a speed tap that's going to give us about 60% airflow. Now, the reason I say 60% is because if it happens to be 65, that's okay. If it happens to be 55%, that's okay. So 60 is right about in the middle. So we're looking for an airflow that's going to be real close to 60% airflow. So to give an example, if I had like let's say I had a 2-ton unit outside, my 100% airflow is 800 CFM. 60% of 800 is going to be about 480 CFM. And so if you have if that normally open contact on that reduced airflow, if you're somewhere between about 450 and 500, you're going to be right in there, like on a 2-ton unit. So it's going to be right about 60% airflow on that normally open contact on the relay. Any questions or comments on the low voltage block wiring before we show you a little animation and we work the relay and you can kind of get an idea to see what it's doing here on the animation in a minute or two. Any questions or comments?
No, I think we're good.
You guys in good shape? All right. So so as we take a look at it and we switch that relay, let me do that one more time. As we animate that and we switch that relay, we find that as we switch that relay, what's going to happen, that S1 outside is going to be energized when we want airflow reduction. So that's the idea. The outdoor unit, when it hits about 60% capacity, it's going to generate a 24-volt signal on S1. It's going to switch that relay, bang, right there. It's going to switch that relay and command low airflow. So the default, when the relay is just sitting there unenergized, it's going to be 100% airflow. But when the outdoor unit commands reduced airflow, it's going to energize the relay, switch that relay, and go to a lower speed tap to give us that 60% or so, that about 60% airflow on that reduced airflow. And so what that does is as the outdoor unit starts screwing back on capacity, when it hits that point, it says, hey, I'm going to give me reduced airflow. This is going to give you better comfort. It's going to give you a better humidity control and all that stuff. So this airflow reduction circuitry is very, very simple, just a simple little relay, but it's pretty important, especially in your area where you guys can get a lot of humidity down there. So that airflow reduction is going to give you a level of comfort just unbelievable with that outdoor unit. Any questions or comments on how that's working? Everybody
No.
good? Okay. All right. Remember now, guys, if you do get a W call, just as a quick reminder, if you do get a W call, say we're in the heating mode of operation, you get a W call. That W call is going to put 24 volts on that high speed tap on the ECM motor. It's going to drive that motor to high speed. And by the way, when that happens, if it happens to be in a low speed, it'll just ignore S1, because remember, on an ECM motor, if I have more than one speed command on an ECM motor, it always takes the highest command that it's receiving on that ECM motor. Also remember that W1 will be present with an auxiliary heat call, with a W1 auxiliary heat call, or during defrost cycle. So anytime we get a W1 or a W call, it's going to drive that fan to high speed. Let's go ahead and talk a little bit about a variable speed air handler. I know you guys have opportunity sometimes, I'm sure, to upsell to a variable speed air handler. So let's talk about that. We're going to do the same thing. We're going to have a simplified block wiring diagram. Now, it should be noted that some of the terminals that we're not going to talk about on the variable speed air handler, because they have nothing to do with the outdoor unit, there's going to be some terminals I just don't show on the PowerPoint for simplicity. You have a HUME terminal, for instance, for a humidifier output. You also have some EAC terminals for electronic air cleaner. Well, that really has nothing to do with the outdoor unit, so I don't show that on this PowerPoint. But just remember that on the variable speed air handler, you're going to have some EAC terminals, you're going to have some HUME terminals, you're going to have some jumpers on the board. We're not showing that stuff right now, only because it's just to simplify the wiring diagram. Now, it should be noted also, you're going to have the wiring accessory for that relay kit of a 002 kit, the HMH7AK002. Now, the kit comes with 2 relays on the board. That's why this kit's important, is you have to have 2 relays on the board, and they're going to be designated RV and S1. And we'll talk about those relays and what they do when we get to that point. And we're going to recommend this kit again for convenience and supplied parts. So one more time, the question has been, hey, Joel, could I take 2 single pole double throw relays and my own biflow filter dryer and make up all my own field wiring? Well, yeah, you can. Of course you could. But hang on a second. The truth about it is, by the time you mess around with all that, you're going to more than cover the cost of just getting this little 002 kit. So the 002 kit is recommended for convenience and for supplied parts. In addition, fellas, please remember, on a heat pump, you're going to have a heat pump thermostat for that BO selection for reversing valve operation. As we saw in our previous slides, that BO selection is going to be necessary for the reversing valve in the heating mode of operation. Let's go ahead and take a look at this. This is pretty straightforward. There's not a whole lot to it. We do have the 2 relays, which we'll talk about, but as far as the basic wiring, it's going to stay the same as we talked about before. B is going to energize the reversing valve in the heating mode of operation, so we have to make sure and have a thermostat with the BO selection, as we mentioned. W2 is second stage auxiliary heat, just like we had before. It's pretty straightforward. W1 is first stage auxiliary heat that's going to go straight outside to the outdoor unit, just like before. It'll bring that on during defrost as well as auxiliary heat call. And then Y is going to go outside as our compressor call, just like before. You guys are recognizing this block diagram because it's essentially the same as we had before. It's just we're dealing with a variable speed air handler and a couple different little designations on the terminals. C is 24 volt common, just like we had before. R is 24 volt hot. That's not going to go outside. And G is our 24 volt fan call. And again, we're going to recommend that, when you set your airflow setting up on on the board itself has some jumpers. When you set that up, and you set up your airflow for the tonnage of the outdoor unit, again 400 CFM per ton. When you get a G call, that'll actually be a reduced airflow on there automatically on the board. Okay, so let's go ahead and talk about these relays. So you've got 2 relays. We're going to take one side of both relays to 24 volt common, which makes sense. We're going to have to operate those relays. They're 24 volt coils on those relays. And then on the S1 relay, the other side of the relay coil on the S1 relay is going to go up and hit S1 just like we had before from the outdoor unit. Normally closed, the common terminal on S1 relay for the switching contacts will go up and hit the yellow wire or Y terminal. Again, looks very, very similar because that's what we did before. Our normally closed contact on the S1 relay. Now watch this. Normally closed contact on the S1 relay is going to go over and hit your Y/Y2. Now your Y/Y2 input on a variable speed air handler, fellas, is going to be your command to the control board to drive it to 100% cooling airflow. So as soon as that board sees Y/Y2 input from that relay, it knows it's going to be full airflow, full cooling airflow. The normally open contact on the S1 relay is going to go to Y1. Now on the variable speed control board, what it's going to do, once you set up your airflow setting on your cool and adjust jumpers, once you set that up to your 400 CFM per ton, you got a 3-ton unit outside, and you set it up for 1200 CFM, the board is going to automatically, when it sees a Y1 call, what the board's going to automatically do, it's going to reduce that airflow to 65%. Let me say that one more time. Once you set your airflow up with your cool and adjust jumper on the airflow settings, and you set it up for, say, a 3-ton unit, 1200 CFM, and when the board sees a Y1 call, it automatically drives that fan to 65% airflow. So you don't have to select a speed tap. The board automatically is going to drive that variable speed motor to 65% airflow when it sees a Y1 call. Any questions or comments on that so far?
No,
Everybody
I
good?
think yep, I think we're with you.
Okay, good. Excellent. Okay. On the RV relay, we're going to take the other side of the relay coil, and we're going to go up and we're going to tie into that B terminal going outside for the heating mode of operation. Because all that RV relay is going to do, that RV relay is going to sit there and energize from the Y signal anytime. So we're going to take 24 volts from the Y signal and go down and hit the common terminal on the RV relay. And then the normally closed contact on the RV relay goes up and hits the O terminal. Now here's how this works, guys. On a variable speed air handler, in the cooling mode of operation, when the air handler is set up for a heat pump. Now let me say all that one more time. On a variable speed air handler that's set up for a heat pump, it has to see an O signal in the cooling mode so the indoor air handler knows what to do for some advanced functions like dehumidification and airflow reduction and that delay, that cooling on delay, and some of those advanced airflow features. It has to have the O signal in the cooling mode to know that. So the RV relay, what it does is when it goes into the heating mode of operation and we energize that B terminal, it's going to switch that relay and break the O terminal. So in the heating mode of operation, the air handler, the indoor air handler, when it's hooked up to a heat pump, it has to know in the heating mode, it breaks the O terminals, and so again, that's the only function of that RV relay is to break the O terminal in the heating mode. And we'll show you that animation here in a minute or two. So that's why we have that RV relay, is to break that O terminal in the heating mode of operation. So the air handler knows it's in the heating mode on a heat pump. In addition, when you're not calling for heat, that RV relay takes 24 volts from the Y terminal and takes it over to R through that relay, over to O terminal through that relay. And so it knows that the compressor is running, and it also knows that it's in the cooling mode of operation when it sees O signal for advanced functions like cooling on delay and some other things. So it's very, very important that on a heat pump, we tell the air handler, on a variable speed air handler on a heat pump, when it's in the cooling mode and when it's in the heating mode. Any questions or comments on this basic block wiring before we do some animations and show you how all that switches and works? Then we'll talk a little bit about some straight cooling application as well. Any questions or comments?
No, I think
Okay, you guys squared away. All right. So as we take a look at this, let's go ahead and do the airflow reduction first. So let me back up and do that animation one more time. Watch the animation on the screen. When we energize S1, we're going to reduce our airflow in the cooling mode. We're going to reduce the airflow just like we did before. We're going to be commanding Y1 in this example. And so we're now at 65% airflow, Y1, from the S1 output from the outdoor unit on that S1 relay. When we go into the heating mode of operation, let me back up one more time. When we energize the B terminal for heating mode, bang, what we're going to do, we're going to energize the relay, the RV relay, and we're going to break the O terminal, thus telling the indoor variable speed air handler, hey, we're in the heating mode of operation. So when we break that O terminal, it knows we're in the heating mode of operation, and that's the only reason that RV relay is necessary, is to handle that O signal in the heating and the cooling mode of operation. Any questions or comments on any of that stuff before we jump into a couple other little things?
no, I think we're on board.
Everybody good? All right. Let's talk a little bit about some cooling only application. I know you cats get some of that down here, down where you are, and so we're going to go ahead and cover that as well. We're going to kind of breeze through this a little bit only because you know, we've already talked about the low voltage wiring. The big thing about cooling only application, you're going to notice we don't have a B terminal going outside. We're just not going to use the reversing valve outside. Now, please write this down. There's a couple things I want everybody to really wrap their noodle around. So if you're going to use this in a cooling only application, you still want to use a bi-flow filter dryer. And the reason is because the heat pump, some of the normal functions of this heat pump is it will go into the heating mode literally just for 10 or 15 seconds sometimes to exercise the reversing valve, just to keep it moving, right? And so that exercise routine, it's going to take you, even though there's no signal for B terminals, there's nothing saying, hey, we want to go into the heating mode. We've had some field reports, that the unit will go through an exercise routine. It'll go into the heating mode, and it might do it for 10 seconds and then go right back into the normal mode, cooling mode. But it's important that we have a bi-flow filter dryer on there, because if it goes through that exercise routine, we don't want to have a liquid circuit restriction, and we don't want to have a problem because we don't have a bi-flow filter dryer on the liquid line, right? The other thing is make sure that when you hook these up in a straight cooling application, that you still use a coil on the indoor unit. Make sure the indoor unit is still a heat pump compatible coil, because again, when it reverses cycle just for a few seconds to exercise, the reversing valve and whatnot, we want to make sure we don't have any restrictions or we don't have any high pressure situations, because the reversing valve, the expansion valve is not a bi-flow TXV. Now, as it turns out, if you're using a Champion coil, all of our Champion indoor coils are heat pump compatible. But let's say you had a retrofit on a brand X inside and it was just an AC only coil. Don't do that with this product. So a heat pump compatible indoor coil and a bi-flow filter dryer, even if you're in straight cooling application, so that it can do its exercise routine without having any sort of blockage or problems with that mechanically. Is there any questions or comments on that if you're going with a straight cool application?
No.
Okay. All right. So other than that, guys, it's pretty straightforward. Our heat strips are going to hook up just like they did before. The problem, or not the problem, but the thing is, you will not take W outside on straight cool application. Because on a straight cool application, we're not going to need any defrost, are we? And we're not going to need that B terminal outside for heat pump operation. So you will not take W outside. You won't take B outside for straight cool. Y terminal will still go outside just like before. C terminal will go outside just like before. And so there's our two wires outside, for common and yellow wire going outside. R terminal goes to the indoor unit only. G terminal goes to the indoor unit only. Now, when you hook up your relay and all that, you're still going to do the same thing as you did before. One side of the relay is going to go to S1. The other side of the relay coil is going to go to common. And so you're going to notice on straight cool application, you're only going to have 3 wires outside. Yellow, common, and S1 for your airflow reduction on your relay. And just like we had before, your common terminal on the relay will be your common terminal for the switching contacts will go to yellow, just like before, to Y terminal. Just like we had before, your high-speed tap is going to be on your ECM motor for your auxiliary heat, which you'd expect when you bring those heat strips on. Your normally closed contact is going to be 100% airflow on the relay. Your normally open contact is going to be 65%, just like you had before, or 60%, 60 to 65%. So it's going to be exactly like you had before on the 8E air handler. The only difference is you're not taking B terminal outside, you're not taking the W terminal outside, but you're still using a biflow filter dryer, and you're still going to be using an indoor coil that's heat pump compatible. So if you do have a straight cool application, this would be the way to do it. If you had that application with only 3 wires outside. Any questions or comments on that before we look at a variable speed situation with straight cool, and then we'll talk a little bit about some airflow considerations as we kind of wrap up the training this morning.
What if you only have 2 wires outside?
Okay, I get that question quite a bit. So if I only had 2 wires outside, I would not have that airflow reduction capacity, would I? And so the unit would sit here and modulate back, but you'd still have 100% airflow. So let's say you had a mild, let's say it's a rainy day and it was mild outside, 80 degrees, 85 degrees, it's a rainy day and it's real humid, you wouldn't have that airflow reduction. And, you could have some humidity issues in the house as it starts coming back, because it's still going to modulate back because it's looking at outdoor air temperature, coil temperature, suction line temperature, and all that stuff. And so it would start modulating back on a mild day, and you might have some humidity issues if you only had 2 wires outside. So that would be my main concern with that, is if the unit was modulating back, but the indoor unit stayed at 100% airflow, you're going to have some potential humidity issues inside. But mechanically, would it work? Sure, it would work. It just wouldn't be as comfortable.
Okay.
So kind of keep that in the back of your brain. I mean, yeah, you could do it, but you basically on those mild days you'd have too much airflow inside, and your humidity control would go in the toilet. So if at all possible, do that S1 circuit outside to give you that airflow reduction, to really give you that comfort inside that you're looking for. Good question. Good question. Any other good questions or comments?
No, I think we got
a little side note. We had a couple contractors in Texas, if memory serves. They only had 2 wires outside. They were doing a straight cool application down in Houston or whatever. It was along the coast. And they just could not get another wire outside. So they kept 2 wires outside, and then they set their airflow up inside to like 350. And that helped. But the best scheme is to have the relay and the airflow reduction. But that's what they did, and they had a pretty successful install without too much humidity problems, because they reduced their indoor airflow to about 350 CFM per ton instead of 400. But they had a good duct system and a filtration system that wasn't going to ice the coil up and stuff like that. So those are considerations to think about as well if you're stuck with 2 wires. Okay. A cool only application with variable speed air handler, fellas, is going to be just like we had before. An area that I want you to really pay attention to, though, you'll see on the PowerPoint, is on the control board itself. If you're going straight cool application with a variable speed air handler, make sure that you set that airflow. You see your airflow settings. You're going to set those up normally, but there's going to be a jumper that says AC and HP for heat pump. Make absolutely certain, if you use a variable speed air handler straight cooling application, that you tell the air handler that is not using that O terminal. Because remember, that O terminal has some advanced functions, but if you go down on that jumper that says AC and HP, be sure and select the AC on the air handler, that jumper AC on the variable speed air handler, to tell that board to ignore that O terminal. And that's what that does. So when you put that jumper on AC, it tells it's on an AC unit outside, a straight AC unit, and to ignore that O terminal. So be sure and do that. Then if you do that, it's going to be pretty straightforward, just like you had before. W1 and W2 will be your heat strips. Y is going to go outside. 24 volt common all the way through. This looks real familiar to you. R is your 24 volt hot that does not go outside. G is your fan call, just like before. And then now, if it's straight cool application, fellas, you don't need that RV relay, do you? You don't need that second relay because you're not dealing with any of the O terminal circuitry. So now it's just going to be just a regular single relay inside. One side of the relay coil will go to common. The other side will go to S1. 24 volt common on Y terminal will go to your common switching point, your common terminal on your switching contacts. Normally closed will go to Y2, and Y1 will be normally open contact on the relay. So as you take a look at that on a cool only application, you only need the one relay. So let me say that one more time. In a cool only application, you only need the one relay on a variable speed product because we're not dealing with the O terminal. And of course, if you have a existing ductwork, we're going to talk. Are there any questions or comments on the block wiring diagrams before we talk a little bit about some airflow considerations as we kind of wrap up the training this morning?
No.
Everybody good?
Wait.
So when it's doing this on whether heat pump or cool, and it's Y1 gives it 65%. Is that right?
That is correct. Good. So excellent question. So on a variable speed air handler, Y1 is going to be 65% airflow automatically on a variable speed board, because what's going to happen is wherever you have your cool and adjust jumper and wherever you have your cooling airflow set up, whatever airflow you have set up on your cooling airflow, when it sees a Y1 signal on a variable speed product, on a variable speed air handler, it's going to automatically, the board's just going to automatically drive the fan to 65% airflow of whatever you have your airflow settings set up. Good question. That is correct.
One energizes to take it to 100%. Am I understanding that right?
So when it sees a Y/Y2, it'll drive the fan to 100% airflow. That's correct.
Y2 takes it to 100%. The S1 is for the output. So essentially, there's just two speeds for the motor.
So the motor, so the compressor modulates between 35 and 100%, correct?
That is correct.
And then how many? I don't know if I'm using the right word. Are there how many stages are there between 35 and 100?
That's an excellent question. There's actually it's one point. In other words, 35 to 100%. So it'll modulate 36, 37, 38. I mean, however many steps that is, but it's variable between 35 and 100% capacity. It isn't like a 5-stage, for instance, like 35, 45, 50, and so on. It's actual steps or stages. It's between 35 and 100%. So it might be at 67% capacity. And by the way, it's a very smart unit. It's very intelligent. So it may see that, it's running a lot at, say, 67% capacity. And so when it hits 67% capacity or 66% capacity, it's going to call for airflow reduction. And then by looking at thermostat activity, how long it takes to satisfy the thermostat and all that stuff, it'll make intelligent decisions on where it needs to be for modulation based on outdoor air temperature, suction line temperature, discharge line temperature, suction pressure, and so on. So there's like 5 or 6 sensors that it's constantly monitoring. to know where its modulation needs to be, and it's smart enough to learn, looking at thermostat activity and outdoor temperature and stuff, is smart enough to learn, optimal points of capacity. So it'll modulate anywhere between 35 to 100%. Good question.
That kind of leads into it kind of answers a little bit of my next question. So we can definitely expect longer run times out of this unit, correct?
Oh, I love the way you think. Yes, you're gonna have longer run times, and which is a good thing, especially in your area of the country, because longer run times means better humidity control and more comfort, right?
Exactly.
Yeah, and so this outdoor unit's modulating, even though it's a conventional expansion valve inside and all that stuff, it's looking at points of modulation. And then when it gets around that 60-65%, it'll generate that S1 signal to slow that airflow down inside. So you may have a situation on a mild day, and that's the whole thing. On a mild day, you don't want this thing cycling off. You want it to continue to run to keep that humidity under control, even though it's mild outside. Does that make sense?
It does, because that's where it was. That's where it was getting kind of fuzzy for me. As I'm like, okay, so we got a 24-volt thermostat wired into Y1 that basically just tells it the thermostat, our little whatever, it's telling it just come on and off. So how exactly were we getting that more advanced dehumidification? How were we getting the longer run times? How are we achieving all that? And if I'm understanding correctly, it's just taking a lot of it's learning from that on how quickly it goes on and off, learning from outdoor temperature, learning from our vapor saturator, our suction temperature, and learning through. Correct.
That is correct. And so there's lots of intelligence on the outdoor board there, and it's just what I like about it is the fact that it's simple to wire, it's simple to hook up, but there's lots of smarts outside, lots of intelligence outside. And when the outdoor unit says, hey, you know what, give me some reduced airflow, it generates that S1 signal, drops you down to your 60-65% airflow at that point. And so now the indoor unit's really quiet, it's running slow, it's running just a little over 50% airflow. And the outdoor unit's just modulating back, and to your good point, extra runtime, extra comfort, extra humidity control, and so on. Because remember, Tame, your unit can't dehumidify, and it can't provide comfort if it's not running, right?
Right. Yeah.
And so that's exactly what it's doing with that modulating 35 to 100% capacity, but we're also optimizing some of that by a real simple relay and a real simple airflow reduction scheme on just a conventional type of air handler. So we don't have to have a fully communicating, like on our very high end stuff, everything communicates and talks back and forth, which is fine. It's a great product, but this gives you some mid-tier options that are just fantastic from a comfort standpoint.
So when it does satisfy and the system shuts down, and then when it comes back on, does it always default to Y2 and then modulate after that, or does sometimes it come on a lower?
That's an excellent question. I don't know. That's an excellent question. My thought is it probably at 100%, and then it'll screw it on back. But that's a good question. I don't know. I've not had that question. Hey, that's great. You get a chance to ask a question, Dave, that I don't know.
And I was also curious. Oh, what am I thinking? I just lost it. One second.
So we have 65 stages outside, essentially, to fan speed.
Yeah. So essentially, did you hear him?
Yeah. So essentially, you've got 65 stages, and the thing's going to sit here and modulate. It's going to sit here and modulate, based on all the parameters I mentioned before, and so, which kind of takes me into the next little thing, some airflow considerations. Let me go ahead and pop that little screen and let's talk a little bit about that. Because remember, on every install, you want to make sure you've got your proper airflow, because it is a modulating system. Airflow is going to be real critical, because what's going to happen if it's looking at suction line temperature and outdoor air temperature and all those things, what's going to happen, fellas, is if we have lousy ductwork or if we have lousy airflow, what's going to happen is that the evaporator is going to get cold, and the outdoor unit's going to perceive that as a reduction in capacity. So we want to make sure, you know, our ductwork is in good shape and we've got proper airflow, because what's going to happen, you know, if I start icing up that evaporator, for instance, let's say I've got a really dirty air filter, or let's say undersized ductwork or whatever, and I start icing that coil up inside, the outdoor unit's going to say, oh, gee whiz, it's just a reduction in capacity. So I'm going to start screwing my capacity back. And so, you know, so like, you know, it really ties into what, you know, your good questions are about modulation and capacity and stuff like that. Well, part of that capacity reduction technology is looking at suction line temperature, and therefore suction line pressure, and therefore evaporator pressure, and therefore if the evaporator's iced up, suction pressure goes down, suction line temperature goes down, we start icing the coil. You cats get the idea. And so the outdoor unit would perceive that as a normal, oh gee whiz, I'm reducing capacity because of my indoor coils getting cold. You see what I'm driving at?
Yeah. Would so not that it would be ideal, but would opposed to like a constant torque ECM motor and then the variable speed, would you be able to overcome maybe some small ductwork issues with a variable speed, so you get your constant 400 CFM that is ramping up and down based on duct? Does that make sense?
I love the way you think. The answer is absolutely. So even though the AE air handler is it's a great product, it works well with this. If you've got a little bit of ductwork issues, or you've got some issues, you know, where you need to push a little more air, the variable speed product, you know, it's not a cure-all, of course, but at the same time, it will ramp up and maintain airflow, you know, along that cooling airflow setup on the board as best as it can. And so if you have really lousy ductwork, there's nothing you can do about it. But the variable speed air handler will allow you to massage that a little bit, to your good point, and it makes it a you know, a more viable option if you do have some marginal things that you just can't fix. So yeah.
I'm sorry, I didn't mean to interrupt. One question I had is, so this might just be a question of terminology. So when I look at the Champion line, I look at the spec data on the lines, like, so for the regular, not the HMH7s, but for the regular, it says variable speed compressor. And then for the HMH7, it says modulating compressor.
Yes.
Like, both feel like variable speed compressors. Am I missing something?
No, you are not missing. It's just a difference in terminology. So the variable speed compressor and modulating compressors are going to be pretty much synonymous with each other. And the reason I say pretty much is because based on the technology, you may have an EEV on the indoor coil, for instance, like on our 21 SEER product. You have an EEV outside, you have an EEV inside. And but on this product, it's just a conventional expansion valve on the indoor unit with an EEV outside. So it does have an EEV outside, electronic expansion valve outside. And so we call it modulating because it is modulating, but it's using variable speed compressor technology. So they're really synonymous with each other when you think about it.
All right. Good. So my sales guy, he could feel in good conscience tell, you know, because customers like, oh, does it have a variable speed compressor? And he's like, well, you know, it's modulating, but it is, yeah, he can in good conscience just say it's a variable speed compressor.
Yeah, because the compressor technology, in order for it to be modulating, it's going to have a variable speed technology, which it means it's going to have like an inverter drive on it and all that kind of stuff.
Okay. What I thought, that's kind of what I assumed. Oh, I think we got another question.
So here. I know I just asked. So 65 out, 2 speeds of airflow inside only. Right?
So inside we only have 2 speeds, whether we have the variable speed or the ECM.
That is correct. So when you think about it, the variable speed allows you to set up airflow on the board with some jumpers, and then it's going to do everything it can to maintain that airflow. On the ECM motor, you're going to go in and you're going to measure airflow and select a speed tap that approximates 60 to 65% airflow. So when I say approximate, let's say you've got, you check your airflow and everything, and let's say you've got a choice. Let's say you have a choice between 52% airflow or 80% airflow between those two ECM motor taps. Well, you're going to pick the 52% because that's as close to 60 as you can get, right?
Yeah.
Whereas on the variable speed product, once you set those jumpers that cool and adjust, they work together. Once you set those jumpers to 1200 CFM, we'll say, that motor is going to ramp up and maintain that 1200 CFM the best it can, based on the ductwork and filter and all that stuff. But it's going to maintain that programmed airflow. And then when you get a Y1 call on a variable speed product, the board's going to automatically take that. It's going to look at your airflow jumpers for cooling airflow, and it's going to automatically take 65%. So when you're on a variable speed product, you're going to get 65% of your programmed airflow, whereas on an ECM motor, you're going to be selecting a speed tap as close as you can get. Does that make sense?
It does. It does. So real quick, you've mentioned, if our O terminal is energized coming from the RV relay, that it has some advanced dehumidification functions.
That is correct.
What does that look like, or what's out of it? Is it
okay? That's a very, very good question. So on the variable speed air handler, you're going to have it's going to be a purple wire on your low voltage wiring. It's called HUM, H-U-M, and that HUM terminal on the variable speed air handler, if the O terminal is energized, it's going to look at that HUM purple wire, HUM purple wire, and it's going to see if there's 24 volts on that purple wire or not. So what you can do on that, you can utilize that purple HUM wire on the control board, and you can put a humidistat on there, a humidistat. And if it's humid in the house, that HUM input on that purple wire, if it's humid in the house, the humidistat is open electrically on a rise of humidity. And so you have a standalone humidistat, maybe mounted on the return duct, for instance, and you have it set at 55% humidity or whatever. If that terminal is open, it will drive that variable speed motor to 82% capacity forever until that humidistat comes down. When the humidity gets out of the house, it comes down and click, it allows that fan to go to high speed. So that HUM terminal is activated by the O signal telling the unit that it's in the cooling mode of operation. So really that humidistat becomes a an extra dehumidification function on the variable speed air handler. And so there's lots of things you can do with the variable speed air handler over and beyond you can with an AE air handler. And that's one of them. You can actually have some advanced dehumidification functions available to you.
There's not a stat that's compatible, like with a dehum, like a stat that would be recommended that's compatible with this system that would, just like a dehum terminal, that would do it without a standalone?
That could be a possibility. I'd have to look at the thermostat specs on there. But basically, as long as you have a set of contacts, 24 volt contacts in the thermostat, or with the humidistat, a standalone humidistat, as long as you've got a set of contacts that will close on a drop of humidity and will open on a rise of humidity, you could drive that HUM function or that dehum function on the variable speed air handler. But the contacts have to work. They have to work in such a way that they close on a drop of humidity and open on a rise of humidity. And if you have that 24 volt signal, close on a drop, rise on open on a rise of humidity, there'd be no reason that you could not have that in a thermostat function if the thermostat is capable of doing that.
Okay, awesome. I got another question.
Yeah.
Two parts.
And if you get to that situation where you're doing all that, please give me a call and we'll walk through and talk through some of that. But that would be a really cool thing, because you're right, because some of your advanced thermostats do have that function. But let's walk through that and talk through that if you get into that situation where you'd like to try that with a thermostat out there.
Awesome, thank you.
Well, fantastic, fellas. The other thing I'd like everyone to remember on straight cool applications, it's recommended to utilize that S1 wire, again, from the outdoor unit for reduced airflow. And if S1 is not use, please consider reducing that airflow to about 350, like we said those guys in Texas were doing, to help enhance that humidity control. The other thing real quick about airflow, guys, I'm not going to go over every one of them, but this is a table that you're going to find in Manual D having to do with recommended duct system velocities. For instance, your main trunk, there's some recommended velocities on your main trunk and your branch runs and stuff like that. So please consider those things. You know, when you're building your duct system, make sure you don't exceed those maximum velocities. And finally, as a final note, please remember that if you've got a filter grill, if you've got a return grill with a filter in it, Manual D recommends we do not exceed 300 feet a minute velocity across that filter. So, you know, just keep those things in mind when you're setting up your airflow, because it's going to be really, really important, like I said, on a modulating system, that we have that proper airflow. Because if we don't have the proper airflow, it's going to perceive that as an airflow, or more specifically as a capacity reduction, like we talked about.
Okay.
So with that, let me, what I normally like to do at this point is I'll go ahead and stop sharing my screen and turn my camera back on, and kind of round out the morning with any final questions or comments I could address for you guys before we secure for the day.
So you may have answered that first. When the dehumidistat feature, if we wanted to use that, it's gonna, no matter what the dehumidistat would be set to, it would take, what is it, Y1 from 100% to 82%? Is that what you said?
Yes, I like that. Good question. So what's going to happen on their variable speed air handler, if you have the dehumidification function enabled with the purple wire like we talked about, whatever the airflow, whatever that board is driving the airflow at normally, it would, if that humidistat is open electrically on a dehum function, what it's going to do, it will reduce that point of airflow. Let's say we're at 1,000 CFM on a 2.5 ton unit. Or on a 800 CFM on a 2-ton unit. And we're driving it along at 100% airflow, and all of a sudden that humidistat opens electrically, it'll take that down to 82% of 800. So what would that be, about 650 CFM, something like that?
What if it was on the 65% airflow? Would it take that down as well? Or
Ooh, I love that. Good question. And the answer is absolutely. If you're on a Y1 call, 65% airflow, yeah, and you happen to open that humidistat, it'll then become 82% of that 65% airflow. So that is correct. So regardless of what the airflow is in the cooling mode, if you have that dehum function, if that switch opens electrically on a rise of humidity, it's going to drive that airflow to 82% of wherever it happens to be at that point of airflow reduction, Y1 or on Y2. That is correct.
Effectively, that gives us now 4 fan speeds.
So effectively,
what was the question again? I didn't hear it.
That's 4 fan speeds then.
Yeah, that's correct. So on the variable speed air handler, you really have some functionality. And here's another one. Let me just throw this at you. If you happen to have the delay jumper on the variable speed air handler set in the humid profile, and it starts out at 50% airflow, then it jumps up to 80% airflow for about a minute and a half on 50%, then 80% airflow for like 6.5 minutes, and then on up to 100% airflow if the call for cool is still there. If you happen to be halfway into that delay cooling ramp, let's say you were at 80% airflow and the humidistat opened up, it would then be 80% of 80%. It starts to get a little mind-boggling, but 80% of 80% of the original airflow. So the point is even during the ramping operation on a humid profile on your delay jumper, if the humidistat is open, it will drive that airflow anywhere along that ramp to 82% of that airflow. So like I said, it gets a little mind-boggling trying to figure all that out. But the truth about it is that dehumidification function is a very, very viable thing, especially if you have a humid environment and you want to provide that extra level of comfort Now you match it up with that outdoor unit, that HMH7, man, you've got a humidity eating machine. You really do. Good questions. Any other good questions or comments before we secure more?
So, a couple things. So I can think about between 50 and 100 reasons why it's horrible. Is there one good reason why the service ports are faced straight down and you can't get core tools in there? You can't do anything with it, especially with one of these 5-ton, 2-story units. Like the service ports are face down and you can't, and you're on a slab in the concrete. Is there any way anyone can change that? I mean, is there one good reason why we have that?
That's a great question. I've not made that observation. I'll be sure and write that down, as a matter of fact, and ask about that. I can ask about that.
I mean, it's kind of a nightmare because you can't get a core tool in there. So, I mean, valve core goes bad, but that's the least of my problems. Just trying to pull the cores out so we can, flow a little easier nitrogen,
Sure.
Trying to vacuum down a 5-ton system with a 40-foot line set, 7/8 copper, trying to vacuum that down. All of a sudden, we're tripling or quadrupling the time to vacuum the system down. Now, the other, we was installing one last week, and the valve core was stuck. It's mounted to a slab, uncook our valves. All of a sudden, we're losing pounds of refrigerant. No way to charge this system up. I got to completely empty everything out, weigh it all back in. So, kind of turned into a little bit of a nightmare. And if you could, I know you wrote it down, but if you could underline it and then tell them, because it's when we looked at it, we're like, man, that seems like it might be a problem. Maybe it's not a big deal. And then now we've installed, 3 or 4, and it's a problem every single time.
Okay. I'll be glad and ask about that.
Because even the little service ports that you showed, like the little, yellow jacket, the little 5/16 quarter-inch adapters, like they barely screw on, like they're hitting the concrete every time you spin them on. Like they're a nightmare.
I wasn't aware the service ports were that tight on that. I'll definitely ask about that.
And then you have to run the copper around the top, so you can't even really lift the unit up without kicking the copper. So we're doing things where we're like trying to move the slab underneath the unit, which is fine for a 2 or 3 ton, but like for a 4 or 5 ton unit, that thing weighs 230 pounds and it's top heavy. So it really is a big deal. Like that's the only thing we hate about it. Like everything else we love, and that's what we hate. And we don't. It's not even like a dislike thing. It's like it's a nightmare.
Okay. I'll definitely pass those on. Excellent.
I had pump one down. I followed the directions. Maybe I just got to do it a second time and there's something missing. There were directions to pump it down by flipping one of the dip switches, one of the 3rd or 4th dip switches out of the 8 on the condensing unit, and it didn't seem to work. So I just pumped it down like regular. Am I screwing the system up?
No. Because and that's the other thing about the HMH7 that I really kind of like. I think of it just as a regular heat pump. So the service procedures that you're doing, just think about it as a normal heat pump. You're going to wire it like a normal heat pump. You're going to have, hook your lines up, do your evacuations and stuff like that. And like I said, some of those concerns you had as far as the ports and whatnot, we'll definitely bring that to the attention of our factory folks.
But as far as pumping it down, there was a system, and it said it started a countdown from 30 down to 1, and when it got down to 1, then you were supposed to close the ports. I went through that. There was one dip switch out of the 8 on the condensing unit that you're supposed to push. Nothing ever populated on my little LED screen, on the little 8-segment LED screen. So I was like, okay. So I just pretended like it was a regular system, got it down to 10 pounds, and just closed off my service ports. Yeah, that's not permanently damaging the system.
No, you're not going to hurt anything. The one thing you want to always remember, though, on a rotary and or a scroll compressor, especially scroll, don't ever pump it down into a vacuum, because what can happen, it can cause the scroll plates to overheat. But these units utilize a rotary compressor, but still good service practice. To your point, take it down to about 10 psi, but don't take it into a vacuum on AC application.
Okay.
Well, good. Well, fantastic, guys.
I'm sorry, we got one more question.
So when the fan, let's say we have the 2-speed fan with no D, what?
Nothing.
It's running running between 30% outdoor unit and 35%, but obviously the fan would be in the same speed. What kind of measurements am I going to notice different on my, gauges or whatever?
Okay, that's a good point. So you're gonna notice you're gonna be at 60% airflow, and let's say the unit is modulated down to like 35 or 40%. What's going to happen as it starts modulating back, you're going to notice that your pressures are going to start coming down. And even though you're at 60% airflow, you're going to also notice that, it's not going to be quite as cool of air coming out, for instance, because we're going to have a little bit higher airflow than your point of modulation.
Yeah.
So as it starts getting lower and lower on your point of modulation at 60% airflow, you're going to notice that it's like you have too much airflow, which you will have a little bit excess airflow at that point of modulation. Normally, though, like I said, the unit is smart enough to where it's going to start looking at thermostat activity and all that, and it will actually shut the unit down just like it normally would, via thermostat shutdown. But at those lower points of modulation, you will notice that you will have a little excess airflow on the indoor coil.
A little warmer.
Do these things run like with a real? I know it's not a mini split, but I know some mini splits run at like 1 degree superheat. Like they get that superheat real low. And I know we don't have the EEV, we're just using the PXV, but does it typically run with like a real low superheat? Is that abnormal?
That's a really good question. So you will find some reduced superheat in the heating mode, because remember that EEV in the heating mode is going to be modulating more specifically. It's going to be setting refrigerant flow on the outdoor coil, not for comfort, but just to be absorbing heat from the outdoor unit and from the outdoor air. So in the heating mode of operation, you may observe, especially if it's starting getting close to defrost time, and you start getting a little bit of ice on that outdoor coil, as you start getting down to lower temperatures outside, especially with a little ice on the outdoor coil, you're going to notice reduced superheats. Now, in the cooling mode of operation, if the unit's charged properly and you're at 100% airflow and you're at 100% capacity, that expansion valve is going to be working inside like it would on a normal heat pump. And so based on your line size and your length and all that kind of stuff, you're still going to observe about, 10, 15, 10, 12, 8 degrees of superheat and so on in the cooling mode, just like you would on a normal heat pump, is that expansion valve. Because remember, it's just a mechanical normal expansion valve inside on the indoor coil. It's going to be working like a normal expansion valve. It's just a mechanical expansion valve and in the cooling mode. And then the EEV outside in the cooling mode is going to be driven wide open, right? Because there's no, it needs to flow freely from the outdoor unit. So it's just going to flow freely. The EEV will be wide open outside in the cooling mode of operation. So at that point, I'd expect 8 to 10, 12 degrees of superheat as that mechanical expansion valve on the indoor coil is working normally in the cooling mode. Okay. So it's kind of a long answer, but did that answer your question okay?
Yes. Yep.
Fantastic. Is there any other good questions or comments we could address for you?
No, I think that's good. Oh, wait.
Well, fellas, I'll tell you what, I'll go ahead and stop the recording at this time. And want to thank you for your training today, but I will leave it open